Hello and welcome back, geometers, to another video lesson with Mr. Forster. October 8th, and your asynchronous tasks for today we will be continuing our work with triangle congruence and introduce these two new theorems for proving triangles to be congruent, called angle side angle and angle angle side. Your homework today, which is posted in Classroom, is through the Kami extension again. Without further ado, let's go ahead and get started. Diving into our first of these two new congruence theorems. The angle side angle, or ASA congruence theorem, states that if two angles in the included side of one triangle are congruent to two angles in the included side of another triangle, then the two triangles are congruent. So our congruent statement for the two triangles to the left would be that triangle HGB is congruent to triangle NKP. When we talk about this included side is the side that is in between, or kind of sandwiched between, the two angles. So it's the side that will be part of both of the angles that are listed. So again, we have this pair of angles, and then the side is the one that is sandwiched between them. And so you'll notice that if I was to describe the lower left-hand angle in either of the two triangles, I could use, for example, BGH for this one, or PKN for this one. And then the other way I would describe the other angle that I know is BHG here, and then in my upper triangle here, PNK. And you'll notice that there's this overlap that takes place, and that side that the overlap takes place, that's what we mean by an included side. That included side is, again, the side that would be used when describing both of the angles. If it's not in both of the angles, then it would not be this angle side angle relationship. Looking at our first proof using this angle side angle idea, here we're given that angles M and P are congruent. We're also told that N is the midpoint of MP. So like we've done with many of our previous proofs, I'm going to start with the given statement. The next thing that I'm going to focus on is the fact that I know that this point here at N is the midpoint of that segment from M to P. And what that means is that those two segments will be split into two equal lengths, or they are congruent. So MN and NP are congruent to one another. So I'm going to state that now. We have MN is congruent to NP, and the reason is that's what it means to be a midpoint, that the midpoint falls directly in the middle of that segment, so we say definition of midpoint. The next thing that I notice looking at the figure is that we have these two angles here in orange that will be congruent. And so my description for them would be angles MNL and angles PNO, and these would be vertical angles. And again, I can't say angle N is congruent to angle N because it would be ambiguous as to which one I'm talking about. There are 4 angles around point N, so I need to make sure that I'm more specific in the way that I describe them. So I'm going to use the 3-letter version of describing angles. Next, I can say by this angle side angle congruence theorem that I have two congruent triangles. I have angle side angle, and we can see that here. I have M and P is my first angle. I have the side MN and NP, and then I have the angles here at the vertical angles. So I have angle, a side, and an angle, and on my other triangle, an angle, a side, and an angle. Let's look at another proof. This time, the information that we're given is we're given that the two segments that are marked with the little red triangle, AD and CE, these are parallel segments. I'm also told that BD is congruent to BC. So much like our other proofs, I'm going to start off by stating my given, so rewriting that as my first step. The next thing that I'm going to focus on is the fact that I have these two angles that are alternate interior angles at angles D and C. So D and C here, because of these two lines or line segments being parallel, those two will be congruent to one another because they are alternate interior angles. So whenever I see this idea of parallel, that's what these two vertical bars mean right here. This means parallel. Whenever I see that, I'm going to look for this alternate interior angles idea. The next thing that I notice is, much like our last one, I have a pair of vertical angles, which we will mark in red here. I'll use my 2 arcs. And again, I can't just say angle B is congruent to angle B because there are 4 angles at that intersection of those two segments. So we have to be more specific. So DBA and CBE would be how I would describe those. You could also say ABD and EBC. as long as both of those two angle statements are describing the angles that you want, which are the two that are marked in red. And now I have what I want for this angle side angle relationship. I have two angles in each triangle, and I have the segment that is part of both of those angles. So I can say that the triangles are congruent by angle side angle. Another congruence theorem that we have that is very similar but has a slight change to it is this one called angle angle side. And so the formal definition of this is if I have two angles in a non-included side of one triangle that are congruent to two angles in the corresponding non-included side of another triangle, then these triangles are congruent. So again, my congruent statement here is triangle CDM is congruent to triangle XGT. And I would say that because I have this angle-angle side relationship. So I have two angles in a single side. And again, those two angles here, I have X and G down on the bottom, and then the non-included side is attached to the angle that has two arcs on it. And in my second triangle here, CDM, again, I have these two angles, and my non-included side is the corresponding, so it lines up in the same position. It's also attached to that one that has the two arcs on it. Seeing this proof in action, this time we're given that XQ is parallel to TR. So that's why we have these little arrows here. XQ and TR are parallel segments. We also have this segment bisector, which we haven't played with too much in the past, but it says that XR, which is this segment right here, this one is the one that is bisecting or cutting QT in half. So what that means, we'll talk about here in a moment. And my task is to prove that these two triangles are in fact congruent triangles. So much like before, I'm going to use my given statement as the start. The next thing that I'm going to talk about, or that I notice, is I have vertical angles. So if we mark these, that are these two intersecting segments here, give me vertical angles. The next thing, because I have this relationship of parallel lines, again, whenever I see the idea of parallel, I'm going to look for alternate interior angles, which I will mark in red. So QXM will be this angle down here, and TRM will be this angle right here. And I have two angles, but I don't have my side length yet. So here, I know that XR is bisecting QT. So what that means is that QT is being split into two equal segments, QM and TM, or QM and MT. So again, the one that is being bisected, QT, this is the one that gets split into two equal segments. So the second one in that statement is the one that's being split. I can't say that XM and MR are the same. We don't know that information, at least not until we establish the triangles being congruent. And at this point, I do have enough information to state that they're congruent because of this angle-angle side relationship. Again, the red and purple angles are in each triangle, as well as the segment that is attached to the purple angle, which is not included because it's not in between the two angles. We have another proof and another new symbol or another new thing that we can use in our proof toolkit. And that's this symbol, this upside down T symbol right here. And what this means is it means that these two segments are perpendicular to one another. So again, that segment XZ is perpendicular to segment YZ. So if I mark those in red, I have XZ is here, and sorry, YW. XZ and YW are the segments that are perpendicular. So I can say that I have a right angle there, and I would also have a right angle here. So we're going to use that information later. The other thing that I'm told in my given statement is that XZ, that vertical segment in the middle of these two triangles, bisects the angle WXY. So WXY would be the larger angle here, which means that if I have this segment that is bisecting, that I have two smaller angles that are equal to one another, which I'll mark in purple. So that means that this angle right here and this angle right here, these would be congruent. So this is a technique that I typically use as I start to fill in some of the information before I even begin the proof to see if I can outline what is some information that I can use and then go from there. So if we continue on, let's start our proof off, again, using our given statement. The second thing I'm going to use is those purple angles that are marked, WXZ and YXZ, which is the definition of an angle bisector. Because an angle bisector, what it does is it splits one larger angle into two equal angles. The next thing that I'm going to use is our no-duh property, also known as the reflexive property, to use that for that vertical segment in the middle. We'll mark in dark red here. So it's going to be congruent to itself. It's a shared side. So we can always use that whenever we have a side that is shared amongst two triangles. The next thing, and this is where it gets a little bit nuanced, is a way that I would put it. And that is, we have to establish that I have right angles to then claim that right angles will be congruent to one another. It's a bit silly, and we'll talk about this in class a little bit tomorrow. We might maybe make an addendum or a class agreement, which would be saying a consensus to allow this to be in one step, but your textbook would teach it as two separate steps. The second step, once I have established that these angles are in fact right angles because of that pair of lines being perpendicular, that's what perpendicular lines do, they meet at a right angle, then I can say that the angles are in fact congruent because that's what all right angles are. They are always the same. That's why we've defined them as right angles. And now I can use one of the two congruence theorems that we've talked about so far, and that is the angle side angle congruence theorem. Again, I have two angles, and I have the included side that is part of both of the angles that are congruent. That concludes the video lesson for today. Again, your homework is in Kami. If you have any questions, feel free to reach out via email. I hope you have a fantastic rest of your day, and I look forward to seeing you in class.